Hi, everyone. Thank you very much for having me here. Um, first of all, I'd like to say thank you for having me. I mean, it's quite weird to say that I can give a webinar in Hong Kong while being at home. I'm from Montreal personally, so it's about 10 p.m. for me. Uh, but with normal circumstances, I don't think I would have been able to travel to Hong Kong. So this is actually a great opportunity for me. So today, what I want to do is give everyone here an overview of what real-time 3D can bring to the AEC space, so architecture, engineering, construction. My name, like I said, personally, my background is in real-time 3D. So I used to work in video games a long time ago and then joined Autodesk for about 6 years where I worked exclusively in real-time 3D and eventually joined Unity as well. So I have a big background in this and it's really something I'm passionate about. And as we see more people enter this space, we're seeing just more and more use cases around the entire life cycle. So what I'm going to do today is share a few of these use cases that our customers actually came out with of how to use this technology to be a bit more efficient in their workflow and how to help with project coordination overall. And really, what's important here is the collaboration between different trades, because this is, especially in these times, it's really hard to get that coordination together and to get different people in the same room and to agree on design choices or clashes in a building or something like this. So as mentioned, there is a Q&A panel, so make sure to write your questions in there. I'm going to pause at different moments in the talk to look at Q&A to see if I can answer some questions. Don't hesitate. Personally, I really love the Q&A sections of these talks because that's when you get the most insights from everyone. So without further ado, I'll actually start. So for those of you who don't know what Unity is, and I'm assuming most people here at this point know what Unity is, but those who don't, Unity is a company that makes a real-time 3D engine. What that means is that it's rendering that happens so fast that you don't even see that it's rendering, so that everything in the 3D scene becomes interactive. So you can start walking around this scene in an unscripted way or interacting with objects, grabbing them, passing them around to a colleague, interacting with light switches or seeing some information in context. And all of this is unscripted. So of course we were born in video games. That's where the technology started. But in the past few years, we've actually seen this technology being used and adopted in so many different use cases, not only in AEC, but also in automobile or retail, or even medical fields, all of those kinds of applications. And it's just starting to pick up. Now, when we talk about the building life cycle, we typically see something like this. Everyone in our field has a version of this slide somewhere. It's the building life cycle. And usually when we talk about Unity, we had classically 3 big use cases where real-time 3D was used in the building life cycle. Those use cases are architectural visualization, the first one. So very high-end renderings, being able to see really in very high detail everything that's going on in a scene. These were mostly used for marketing purposes or sometimes in higher end projects during the design phase, but very rarely. Now, the other use case was pre-construction, being able to simulate what the construction site would look like. We'll get into that a bit later. But the other one was VR training, and this is when it really started to take off, when the first Oculus headsets came out, when the HTC Vive came out. This is when real-time technology actually started to gain a lot of traction. And we're talking already maybe 2 or 3 years ago where these applications started to boom. And this is one of our early use cases, actually dating now I think from 2018 already, where Haskell started doing safety trainings for job sites before construction workers actually went on the job site or before the job site was even ready. Now I did mention high-end visualizations. So this is architectural visualization again. This is an example of our London office where we recreated a virtual version of our office to test layouts, to test lighting, to test material options, to really make sure that everything was up to par before we got started with these constructions. This is very hard to achieve though. Results like this are not very hard, but you know, there is some work to be done in here. And another example in virtual reality, I'll play this video, hopefully it goes through properly, but is the Brisbane airport made by Oricon, where they actually used virtual reality to spot not only design issues, but also security issues in their prototypes and in their designs. And if I move forward here, you'll actually see the user in real time being able to change things like ATM or vendor machines or even signage to make sure it's in the optimal position so that everyone can actually get the information they need at the time they need it. Now, this was really only the beginning of, let me skip that slide. Yeah. This was really the beginning of real-time 3D. And the reason it didn't take off that rapidly is just because how hard it was to bring your 3D models into a real-time environment. And if we look at a historical view of what the workflow looked like for real-time 3D, it looks something like this. So you had your design software, which in our case is Revit in most cases, and you had to export to a format called FBX. From the FBX file, you imported that into 3ds Max. And in 3ds Max, you did a lot of different things. You did some kind of magic there. Typically, that would involve merging objects together, getting rid of unwanted geometry because the models were so big and so clunky, some material work, all of that. Then you'd export that to FBX again, and then into Unity or Unreal if that's your engine of choice. And that was the typical workflow. There was no way around it. Now, there's a few problems with this workflow, mainly the fact that it's not iterative, but really what it comes down to is three big problems. The first one is that all the BIM data that you have on your Revit model is completely lost to you. We're talking about all that metadata that is embedded into the Revit model attached to the geometry. Things like construction phases or area or anything relevant to that model just loses all its intelligence, because once you reach the FBX file format, that data doesn't pass through. The file format just doesn't allow for that kind of data to follow along with the model. The second problem is that models are huge. They're enormous and they're not meant to be consumed by a real-time engine. Because classically in a real-time engine, in a game scenario, for example, the entire scene is curated. There's a game designer or an artist that creates everything with the intention of going into a real-time engine. When you come from software like Revit or Navisworks or even SketchUp or Rhino, everything in there is what we call parametric. So the data in there does not exist in terms of real-time 3D, which handles triangles and polygons. So when you translate those models from parametrics to the polygon world, it blows up in size. They are huge. And we're talking about airports or entire city blocks, sometimes even entire cities that you want to be able to bring in to a real-time environment. Now, the last problem is that everything is one way. So when you did that pipeline from Revit to 3ds Max to Unity or Unreal, and something changed upstream, let's say a designer wanted to make a change in the Revit model, well, you had to go through that entire pipeline again and again and again as iterations went through. And when we talk about that 3ds Max step, Depending on the size of the model, that step could actually take several days, if not several weeks. So the power of iteration was very, very limited. And for those reasons, uh, real-time 3D projects were kind of limited to only the biggest projects in a firm. Because in a firm, typically you'd have maybe a handful of 3D visualization experts, maybe 4 or 5, up to 10 if you have a big firm, that really concentrate on one project at a time. And that will necessarily be the biggest project because it can take weeks to churn out one of these real-time experiences. And this is kind of what we wanted to solve with our partnership with Autodesk. Because our vision here with Unity is not to only cater to these 3 use cases, but we saw the value in bringing real-time 3D through all of the entire building lifecycle, not only in visualization or training, but also in design review and in design itself, or in simulation, or all these use cases can benefit from real-time 3D experiences. And we saw the opportunity with Autodesk to work together to be able to bring better experiences to the market. And this is how Reflect came out. Initially, we planned to only have, interestingly enough, we only planned to have a Revit importer into Unity, but the scope of Reflect kind of blew up from there because we saw more and more problems along the way that a simple importer couldn't solve. So we launched Reflect about, was it 6 months ago at Autodesk University in December or in November last year. And from there, we've been iterating on it to make it more powerful, support more platforms. And I'm just going to give you an overview of what that looks like. So typically the way it works is we have these third-party software. For us, we started with Revit, then we added SketchUp and Rhino as kind of test beds for new use cases. And today we're actually announcing the support for Navisworks that will come out later this week. But we start with these applications, and these applications have a ton of data. And the way it works is Reflect will take this data, not the files, the data itself, and push it to the Reflect server. Now, this server lives locally on your own machine, but we also have a cloud version coming out this week at the same time as our Navisworks plugin to be able to share between different people at different locations. Now, once the data is in the Reflect server, we then can push it out to any device that of your choosing, whether it be a PC or a Mac or an Android device or iOS. All those systems, all those devices are supported by Reflect. And the interesting part here, and this is when the collaboration comes in and the different collaboration between trades, is that this is a multiple to multiple connection. So what this means is that we allow you to push data from different upstream software into Reflect. And we also allow you to view all these models at the same time, no matter where you are. So what this means is, let's say, for example, you have an architect working in Revit with their master file. They can push their model to Reflect. At the same time, there's an MEP engineer who's working on the MEP system for the same project. They can also push their project to Reflect. And if at the same time there's, I don't know, a landscape artist working in SketchUp for the surroundings, then they can also push their projects to Reflect and synchronize their models there. Now, at the same time, what happens is that on the viewer side, as many people can be looking at that project at the same time. So I can be on my iPad and everyone here could be on their PCs or on their Macs looking at this model, and you're going to see updates in real time. So what that means is that if my MEP engineer changes something in the Revit model and pushes those changes to Reflect, everyone watching those projects or that project will see those changes in real time. And let me show you what that actually looks like. Hopefully this is smooth and shows exactly what Reflect is. This is actually Navisworks today and how you would navigate a model in Navisworks. So you see we have a Reflect plugin at the top. And once you click on export, what you do is simple. You create a new project for this data to be hosted on. So we're going to just enter technical school here. And from now on, the project is synced. This data has been pushed to the project. Now, once you're in Revit, what you can do is, well, here he's just showing the cloud workflow, but what you can do at this point is share this project with others in your organization. So for example, I've shared my project here with a bunch of my colleagues. And now that this Revit model is synced, I'm going to pause here and just say that this person in Revit is called Leo, and my colleague here showing the top right screen is Brian. Now what Leo is showing is a model that's live synced with Reflect. So what this means is that every time he makes a change to the Revit model here, you can see Brian will actually see the changes in real time. I'll back this up just a second so that you can catch it. So Leo will actually change the wall on the left here for curtain panel, and Brian will see those changes in real time. Now Fred, another one of my colleagues, is looking at the model and trying to align the sun so that it actually impacts the model the way he wants. And now he's saying something to Leo like, oh, you know, I wish there was more sun in this building so that we can open it up and see a bit clearer inside. So Leo goes ahead, changes that curtain wall, and on the other side of the world, Fred is in France, he actually sees those models in real time. So another example of this is when you want to coordinate, for example, the MEP system in the same model. We use the technical school a lot just because we work with a lot of models from our customers that we can't show. But for example, here Leo is just adjusting the MEP system and Brian at the same time can see all of that. This is another example where Brian is just highlighting the structural elements, navigating around, and when Leo actually starts changing the materials in the model, well, Brian will be able to see that in real time as well. So the floor here will change. And that is, in essence, what Reflect is all about. So it enables a lot of people to collaborate in different ways in the same model. That is really the essence of Reflect. So one of the things I want to mention that's really important here, because this is where we're going to go with the rest of this webinar, essentially. One of the key differences with Reflect is the ability to customize it. So what I mean by this is that all these plugins, sure, they can push data to Reflect, but the viewer that you saw Brian and Leo working on is actually a template that you can bring into Unity. What that means is that we give out the entire source code of that application so that you can take it and customize it to your own workflow. Because we know that you're not going to be able to address every single use case right out of the box with any application out there. And that was kind of the first things that we realized when talking with Autodesk about 2 years ago and talking with clients for the first time, is that every time we had a suggestion for a product or a software or a solution that could be beneficial for everyone, someone would always come up and say, yes, but in my company, I work this and this in that way. And so the solution will enable people to customize their own workflow so that they can take Reflect and bring it into their own pipeline, essentially. And this is what a few of our users have done. And this is really where I want to highlight a few things. So before I highlight some customers using this, the reason people are looking to this kind of solution today is repeatability. As I mentioned before, in a typical firm, what we saw is that there's a small team dedicated to visualization, let's say 5 people. And these 5 people are working on one project at any given moment. What that means is that there's only one project in the firm that can benefit from visualization at any given moment. And usually that's the biggest project. And to scale to every single project, you'd have to take that team of 5 people and multiply it by the number of projects, which obviously no one's going to do. It would be way too expensive. Now, with this approach, the Reflect viewer, the customizability, what that means is that as soon as you customize the viewer to a specific workflow, that viewer can now be taken and be applied to every single project you have in your firm without needing the expertise of that dedicated visualization team. Because essentially the viewer is an empty shell. It doesn't contain any models in it. It doesn't contain any data. It just contains features and functionality that then the engineers or the architects can use themselves and push their own data to it. So suddenly we see this being able to scale real-time visualizations across an entire company without needing to hire more visualization experts. Now let's dig into what a few of our customers have done. This is when it gets fun. So the first experience that I want to show is Shop Architects. They are a New York-based architectural firm. They were one of our earliest partners with Reflect. And really the first thing they wanted to do, funnily enough, is nothing very fancy, nothing intricate. They just wanted to brand their viewer. They wanted to take this visualization tool and put their logo in it, which is something that, funnily enough, is not that easy to do with other solutions. So what they did is they took our Reflect viewer, they slapped the Shop Architect logo onto there, and then they could bring it to clients or to boardroom meetings or to any other meeting and just start using this customized viewer branded with Shop Architect. And it really gave that personalized touch. Now, of course, that's just the first step. The next thing they did is starting to bring this on site. So what they did is they took our viewer, once again, and they added their own shop QR codes for augmented reality tracking. And they brought this on site to be able to visualize the construction before it was actually started or while it was going on. They used it as both a guide for on-site workers as well as a way to track construction progress. Now, our viewer does support tabletop AR, so you can take the model and put it on the floor or on a table and see it in miniature. What Shop Architect added here is the way of tracking the model with the QR codes, and also the way a way to visualize these 2D plans in real time. Right there, as you can see, so that as you are on site, you can have these 2D plans right next to your 3D models and 3D visualizations right next to each other, so there's no more context switching. Now, the next thing I want to show you is the acoustic simulation that one of our customers came out with. This essentially is a way to visualize the acoustic, the way sound propagates within a space. Now, of course, we all know that audio can be an important part of the real-time experience. And yes, you will hear a sound. But the interesting part about this is that you could actually see how the sound wave propagate within a space, as well as how they bounce and where they stop. And this, again, I have to stress this, this is a simulation that they've made in a custom viewer, and now this is available for them in every single project that they have. So you can import any model at this point into their own viewer that they've made and run this simulation at any given point. So it's not hard-coded to a model. It's not a specific application for, a hospital or a school or anything. You can bring in any generic model into the simulation. Now, when it gets a bit more interesting is when we started seeing people drive construction sequencing with Reflect from their models. Now, classically, how you would do something like construction sequencing, and I'll forward a bit, so that you can see here the model actually getting built over time. So the way you would typically do this, I'll pause the video for a second, is that you would bring the model into Unity or into 3ds Max or into Unreal Engine or whatever your tool of choice is. And then you'd start creating an animation. That means that you have a timeline in these tools and you have to turn on visibility of every single object at any given moment and then play that timeline back. And it's very, very time consuming. And of course, it's done in a tool that your architects or your VDCs or your engineers are not familiar with. So they have to use this new tool. Now, what this customer has done is all the data that fuels this visualization is actually embedded into the Revit model. Um, that data is then driven also by a spreadsheet that was driven by created from their MS project files. So all the sequencing, all the planning, and all the data that comes in the simulation is actually driven from the Revit model itself. So what that means is that as an engineer builds the Revit model, what they do is they input phases or construction timings into the Revit models, so that once you get into this specific viewer, that data is interpreted by the viewer and will automatically run this sequencing. And you can see on the left side, the project actually also contains the concrete poured and the cost estimation for this entire project, as well as a few empty objects in Revit that are then replaced automatically in the viewer so that you can actually see some of the logistics on site. This part is not very detailed yet, but we're working very closely with this company to keep going on this project, and it's getting very interesting. So next part, it was part of the same project, but we kept going on the same theme. Of course, these models are just the samples from Revit, because as we build this, we're not allowed to use the real models that we're building them on, but these are great showcases. So this is an example of an evacuation simulation. Now, big caveat here, it's not an actual high-end simulation, so you can't use this for any certification or anything, but it does allow you to get a visual representation of where people would start and finish when there's an emergency to evacuate the building. So the way this is done, and again, it's in a generic way, it doesn't need to be done with this model, is that once the model is loaded up into the viewer will build something we call a nav mesh, which is essentially a description of where people can walk in your model. Now, we've actually added in Revit a few hotspots that designate where people would start, and then we just highlighted the doors. We've tagged them with special metadata in Revit, and the viewer essentially interprets those exits and tells the people that are spawned in my viewer to go find the nearest exit. So that once you run the simulation, and again, all the data is driven from Revit, you can actually see the people starting from a point and trying to find the nearest exit. And that way you can probably look at congestions and wherever where there's a room for improvement, essentially, for this kind of thing. Next one I want to show, and this is a pretty classic one, is the SunPath simulation. So we have a technology called HDRP. It's our high definition render pipeline. So in this video, we have the very high-end path traced sun study, so that you can see how the sun will behave over time. We've actually seen this in the video before, but this is a very high-end version of this. And in the next slide, I have the same thing, but this time in virtual reality in a much lower resolution rendering, so you can really focus on the clean cut shadows depending on time of day, hour of day, time of year, and all the parameters that you want. You can also rotate the model so that you can see the impact of the shadows or the sun on your building as it goes in. And this is all done in virtual reality, so you can really be immersed in that feeling. So I did mention earlier that we are going to release a new version of Reflect this week, which supports cloud projects as well as Navisworks. And Navisworks is really another beast. And I see there's a question. I'll pass through this Navisworks section and come back to the Q&A right after this. So Navisworks is just another beast. There's so many different models that can come into Navisworks, and they're very, very different. Actually, the models you see in Navisworks are not houses or hospitals or even schools. They're much more industrial. They're piping, and they're industries, they're silos. They're very, very heavy in geometry. And on top of that, the metadata or the BIM data on these models is really, really diverse. It can come from anything from the Revit BIM data to scheduling tasks to anything that Navisworks supports. Because Navisworks actually supports something crazy like 80 file formats, and it's known to be this aggregation tool. So we've only skimmed the surface of a few users, of a few different use cases that our users have started to use with Navisworks. Because we haven't released this yet, so only a handful of beta users have tried it. But I did want to highlight some interesting ones. The first one is piping. So as I mentioned, from Navisworks, a lot of the data that comes in is piping. Whether it be for oil rigs or refineries or anything like that. But it's very, very important for Navisworks users, especially when you're doing BIM coordination with different trades, to be able to see not only where the piping comes in, but also where the clearance is for maintenance. So questions like, will the manufacturing or will the machining actually fit in this space? Can we get it in? Do we have the clearance to bring it through the door into my factory? But then also, once it's installed, can I actually walk in this space? Do I have enough room? Or even soft clashes, things like, do I have access to this maintenance panel after the piping is installed? What if I have to maintain this piping in 5 years? Will I be able to access it and get the clearance needed to actually do this? So we've done a few AR trials with a couple of users on Navisworks, and we have one that actually did something quite different with this and went on site for some roofing projects. So this is a user in Italy who started using our Navisworks integration to do pre-visualization of his roofing projects. And this is very recent. You can even see him with a mask at the beginning. Where he actually wants to see where the panels, where the woodwork would actually go on his roof before he starts constructing. And he used something very simple. Again, he used some QR codes, so some printed reference trackers, so that he could align the roof in a very, very easy way. So I'm going to take a pause here, and please add some questions in the Q&A before I go into the next section. I see a question already. It says, what if I have rendered my Revit model in V-Ray, Lumion, Enscape? Can I still view the rendered material in Reflect Viewer through the Reflect server? So the question is yes, you can absolutely do that, though the thing you're going to want to watch out for with Lumion, Enscape, V-Ray, all those softwares, including Reflect, Unity, and Unreal, by the way, as well as 3ds Max, all these software use different materials. So the end look is not going to be the same on every software. And this has been a huge problem in the industry for quite a few years, especially since real-time 3D moved to non-gaming application. Because in gaming, like I said, everything's curated. You have artists who will create materials for a specific purpose. Now, when you come into the Revit world, Revit has its own materials, the Revit shared library or the Autodesk shared library. And those are physically based materials, but they're not meant for real-time 3D. So they have parameters that need to be interpreted by these software to be rendered. Now it's easier for something like V-Ray to interpret these materials because they can do path tracing. And our HDRP, our HD pipeline, render pipeline can also do path tracing. So you're going to get more accurate material with those things. But then when you get into Lumion or Enscape, for example, you have to be very cautious with material. Enscape does do some path tracing as well, so you'll have good results there. But in Lumion, for example, you're going to start replacing materials. They offer a big library of materials. I hope that answered the question. If you have any more, please don't hesitate to go into the Q&A panel and keep typing. Okay, so I talked about a lot of the use cases that our clients went through and our users went through, and a lot of these were customized viewers of Unity. So I didn't want today to do a deep dive to learn how to customize the viewer because, first of all, an hour might be enough to scratch the surface, but for a really deep dive, it takes maybe a bit longer to get used to it. You also have to learn Unity quite a bit, or at least a bit. So what I'll do here is I have a series of resources that I want to share with everyone, especially this first one, the digital webinar series. This is a series that we decided to start because of COVID. We had actually planned to go on to a bunch of conferences, to AIA, to AU, to all these different conferences, and give classes on how to use Unity, how to use Reflect, and how to use real-time technologies for collaboration and immersive and everything. But because of travel restrictions, we decided to do these webinar series, and we're doing one every single week. So it's a lot of work for us, but we've had really, really great success with them. A lot of people have registered. There's a lot of interest. So we've done 7 so far, and we're actually going to keep doing them. We're extending the series because people are asking for more. And the one I want to recommend is called How to Use Metadata for Construction Sequencing and Clash Detection. It's one of my colleagues, Leo, that made this webinar or gave this webinar, and it really goes into the details of how to leverage metadata or BIM information on your Revit model into the process, into Navisworks and into Reflect to create these customized experiences. Now, the second resource I want to share is Unity Learn. It's all free right now, and we have a new series as well that came out maybe a month ago that explains how to modify the viewer, and it really goes through every single example that I've seen, that I've shown today. So it goes through branding, augmented reality, sun study, even stuff like adding a measuring tool to Reflect. It really does a deep dive to show you how to do these things. Now there's another Q&A. It says, does this Reflect viewer support computer-assisted virtual environments, so cave systems? It does not out of the box. What I mean by out of the box is if you install Reflect, it comes with a viewer, and that viewer will support PC, Mac, Android, iOS, HTC Vive. Now, what happens, as I mentioned, is that you can take this viewer, bring it into Unity as a template, and from there add support for any device. We actually had one of our partners showcase their own cave system working with Unity with Reflect at Autodesk University last year. From what they've told us, it took them about a day and a half to get started, to actually get some results, to see an integration, and then maybe another week of polish to make sure the demo works properly at Autodesk University. So all in all, maybe 5 to 6 days of work. But again, once it's running in the cave system, it'll run for every single project that you have. So you don't have to redo this work for every single project. So keep the questions coming from now on. I'm going to keep an eye on the Q&A panel, and as questions come in, I'm going to try and answer them live. I really, really enjoy the Q&A section, if you haven't noticed. So I'll keep an eye out. But while I wait for questions, I'm going to talk about future work a bit. So the first question for everyone, especially at AU Hong Kong, is going to be, when do we have Tencent support for cloud? Because today we are running on Google Cloud, so we are working on Tencent support to be able to make sure that we work everywhere across the world, so that we can share projects not only in the US, not only in Europe, not only in China, but really everywhere. I don't have a date yet on when this is going to happen, but it is going to happen in 2 phases. So the first one will enable you to use what we call a project server in Reflect. So that means authentication as well as registering projects, but all the data will still be local. And on the second phase, we're going to support Tencent Cloud, full-on cloud, where you can actually host the data on the Tencent Cloud and share it everywhere. The next question I typically have, and I have a Q&A here before I go into the next section, is how much is the service of Unity Reflect server? So we don't have a pricing right now for the server, but the license for Reflect is $690 a year, and it is for a publisher. That means that if you are a user of Navisworks, Revit, or Rhino or SketchUp, you need a Reflect license. But viewing is free. So you have all the viewers, as many as you want for free, so you can have as many people watching a project, and all of that is free. It's really just for publishing data that we charge for. So the typical next question that I get for Reflect is, how big of a model can you support? And this is a very tricky question. I mentioned it before, one of the main problems for real-time 3D is performances. These models that come from Revit, Navisworks, they're huge. They're not meant to be rendered in real-time 3D. And to give you a benchmark just for some numbers, a small house like the Revit sample house that you have will typically have around 5,000 to 10,000 objects in there. I'm talking about individual pipes, doors, panels, windows. For example, in Windows, every single panel is an object. Railings are very heavy as well. And that adds up to about 1 million polygons or triangles. That's the equivalent of a pixel in 3D. And will weigh about 100 megabytes. It's not too big. It renders on a phone pretty well. You can do a virtual reality, no problem. But then as you scale up to bigger modules, for example, we had a hospital at our AU demo last year that had about 300,000 objects and 300 million polygons. And that model weighs around 3 gigabytes when exported. And to give you another example, we received a model from Autodesk. It was a hotel, and the hotel itself wasn't that big, but every single room in that hotel had furniture in it, had piping, had faucets, had a refrigerator, a table, a lamp. So there was a lot of objects, and there were a lot of objects in that hotel. And what happens is that once you reach a certain size, like 3 gigabytes or 4 gigabytes, or even 10, 20, 30, like we had an oil rig come in from one of our users from Navisworks that ended up with 3 million objects and 3 billion polygons and 30 gigabytes on disk. These types of models no longer fit on your computer. So when you want to render them in real time, you have to load all this data into RAM. And your computer, your phone, does not have enough RAM. Not only that, but if you could load it up into RAM, it wouldn't have enough processing power to render these in real time at 30 frames or 60 frames a second. So we're trying to address this as much as we can with Reflect, and this is something we're working on right now. So the way it works is, and our goal here is to bring an oil rig, a complete oil rig, like 3 million objects, 3 billion polygons onto your mobile phone. Not only that, but to something like the HoloLens, where you have to wear it on your face and not get overheated. So the way we're doing this, or the way we're approaching this problem, is through what we call a pipeline. And this is when I get excited, because this is technology and I love this. As a technical product manager, this is what I live for. So, sorry. So what happens is that instead of getting all the data onto your mobile device right away and trying to load it, what we're going to do is we have a camera in Reflect that tells you, here's what you're looking at. And from that camera, we can determine what needs to be displayed in the scene. So what is not inside the camera frustum? So what is behind you, for example? We don't need to render that. What is behind a wall? If an object is behind a wall, we don't need to render that. We don't even need the data. So based on what I see, based on the camera, I can ask the Reflect server what I need to draw, and then the Reflect server can hand me the data so that I can render it, or I can save it, or I can put it in memory. And this is what we call not pixel streaming, but data streaming or object streaming. So based on this, we can then stream the data to your device on demand so that suddenly your model that was maybe 3 billion polygons, you only need a fraction of that to actually see the current scene based on your camera position. So we stream the objects on demand as you move around the scene so that you can actually scale these models to a big, huge model that you can actually see on your phone. And with this kind of technology, what we're hoping to achieve is to be able to not only fit your oil rig, but all kinds of models onto your phone that streams on demand so that you can scale not only to one model, but a whole city block or an entire city or an entire project. Because as we all know, when you start collaborating with other trades and when you start collaborating with other people and other projects and other firms and contractors, there's a lot of data that gets shuffled around, and it doesn't only come from Revit. It comes from Navisworks, it comes from Plant 3D or Civil 3D, or it comes from Inventor or from CATIA, and those models get huge and that data accumulates. So it's natural that we can't take the approach of just getting the data and putting it on your device as we have been doing for the past 2 years. We need something new, and this is what we're working on with Reflect, is being able to get that data in real time in front of you in the right context. With that, I want to thank you. And I'm going to keep an eye open on the Q&A. Hopefully we get more questions. I'll stay here. We have about 12 minutes left. If there's any questions, don't hesitate. And if not, I'll hand it over to the hosts. And don't hesitate to reach out to us directly. You can contact us, and I'll put this in chat. We have a support email. It's support-reflect@unity3d.com. Or you can simply shoot me an email directly. My email is david.menard@unity3d.com. I'll post these in chat if you're interested. There is a question in the Q&A while we wait for the survey. The question is, can you tell us more about Unity's IoT analysis? That is a great question. So IoT is actually a really, really tricky subject because there's so many devices out there that stream data. The important part is that most of this data goes through some kind of connection. There's only a handful of connections that you can actually go through to support live data. There's WebSockets or sockets, typical sockets, or REST APIs, or direct streamable data. All of those are accessible through a C# API. That's the good news. And all of what Unity does is in C#. So it's actually very accessible. If you want to add IoT capabilities to Unity, it's fairly straightforward to do. Then the second layer of that question, I guess, is the integration with third-party components. Again, things like, I forgot the IBM one, but when you have a service provider for IoT devices, typically you'll have a dashboard with some kind of API. Most providers will have a RESTful API. So you query the RESTful API. It's a URL essentially that you put your device ID or an address in there, and you receive the data back. So it is a polling mechanism, and all of that is possible through our C# API. It's actually pretty straightforward to do as well. So the real challenge with IoT devices, now that we have a way to actually interface with those devices, is matching the device to your real world counterparts. Because let's say you have a lamp in Revit, and you want to make sure that that lamp in Revit has a connection with its real world counterpart. Well, you have to make sure that the Revit lamp has the metadata to be able to connect to the real world counterpart. That means that in your IoT dashboard, whatever you're using, let's say it's IBM, you probably have a SSID attached to that lamp or to your smart lamp or a device ID or anything like that. Once you have that device ID, you can attach it to the Revit model or the object in the Revit model, or you can attach it to a game object directly in Unity, no problem. And once that data is there and you can make that connection, then transferring information for visualization is the easy part. I hope that answers the question, Owen. If you have more specifics, keep posting in the Q&A and I'll try and go deeper, but I am by no means a IoT expert. My pleasure. The conversation or the topic of smart cities or facility management or IoT devices really comes up a lot and very frequently. So probably next year we're going to start looking at that a bit more specifically to see how we can help, because there's a big visualization part to all of that.